All right, this will be a video for the belt tensioner. We'll start off with a sketch for the perimeter, the slots, and also this boss area here. We'll extrude that to the thickness, and then we'll actually create this octagon here and extrude it with the draft. There's a 5-degree draft on all sides. I'll start a new file. We are in millimeters, so make sure that you have changed your units to millimeters. We'll just name this belt tensioner. And make sure that we are saving this to some place that we can access. Millimeters, model, belt tensioner. We'll say OK. We'll start with a sketch on our top plane. And we're going to start off actually going to make a circle here. We're going to actually sketch this circle. This will be our origin. We'll add a circle here. We're also going to put in a circle on this side. We're going to make it tangent with this line and this line. Same thing with over here, tangent and tangent. This will be a circle. We're going to make sure that these are both on the horizontal axis. Well, this will be at the origin. We want to make sure that this circle is on the horizontal axis. That way it's constrained to that axis. And we'll go from there. So we'll start with a circle. With the circle to at the origin. This has got a diameter. Now this is a diameter of 42 millimeters. The rest are radii. So it's an R14. This is the only one that is a diameter. It's 42. Go back to NX and we'll place the other circle on this side. And we want to make sure it's constrained to the horizontal axis. Now this is a radius, so I'll left click on the dimension and notice it's the diameter. So before I type in any value here, I'm going to right click and I'll say convert. So I just right clicked on the text right. So right click, convert to radius, and I want that to be 15. And we know the distance from end to end is 128 millimeters. So make sure I'm selecting end to end here. Don't click on these center points. We don't want the center to center. We want end to end to be 128 millimeters. Now to do this part, I'll actually go to the profile tool. I'll start on this circle. I'll do a straight line. I'll do an arc, and then straight line to the circle. I want them to be tangent to each of the circles, but just to be safe, I'll actually go back and make sure everything is tangent after we lay down those arcs. So back in NX, we'll go to our profile tool. And I just want to make sure that I'm selecting a point on the curve of the circle here. So notice that my snap point is on the edge of the circle. That's what I want. I don't want it to go to the center, on the edge of the circle. And I'm just going to go up. I don't know exactly where it's going to be, but I just want to place it up here somewhere. Place the line right there. And then we'll do an arc. Try to make sure there's no auto constraints put on, because we're going to go back and assign those later. And we're going to make sure that we come down here and end with a point on this curve, just like that. I'll do the same thing for the other side. And I'm going to go through and I'm going to say a make tangent constraint and make sure that everything is tangent. Make sure that we have create persistent relations turned on. Okay, so make sure that we have that turned on. And I'll go to my make tangent constraint. I just want to make sure that these this curve is tangent with this arc, and I'll do that for all of the lines transitioning into the arcs. So to make sure everything is tangent. And on the last one, I can just say okay. And now I know that everything is tangent. And the other thing I'm going to do is I'm going to add a make vertical constraint to this arc center and this arc center. Those to be aligned vertically. So I'll do a make vertical here and here. That's going to sort of center them up for us so that they are sort of connected together in a sense. All right, next we'll do this center slot here. So we're going to do this slot. Now the center of this arc here, it is coincident with the center of our arc here. So I'll make our slot 10 millimeters in width, and then it's 56 millimeters from end to end. And then we'll add those coincident constraints. So back to our profile tool, and we'll just make a slot here. So we'll use an arc. We said 10 millimeters. And then 56 millimeters from end to end. We do want this to be centered on the horizontal axis here. So I'll do a make coincident constraint for the midpoint of one of these two lines here. And I want that to be coincident with our horizontal axis. And I can go ahead and make coincident our center point of our arcs here with the center point of this arc. Make coincident. Okay. This. Same thing with down here. And these are going to be, these here are R15, R14. So now notice here, this is already a radius. So all we have to do is just put in the 14. What we can actually do here is we can do a make equal constraint. We can do an equal radius. Say, okay. We're told that slot and the arcs are 43 millimeters from the center here. So I can say from our horizontal line to just one of our arc centers will be 43. All right, it's saying sketch is fully defined, but we still have some more stuff to add in. We have this slot here that we're going to add in. So you'll notice on here that we still have this circle, though. We don't need this whole circle. We really just use that to get this arc, this radius. So we will go up here to trim, go to trim, and we're going to trim the left side of this circle. So this is the part that we don't want. So it's highlighted red. I'll go ahead and click on it. I can close out of that. So that's how we get that radius there. Now we'll add in the slot that goes here. profile tool, and we'll just add a slot. This also needs to be aligned with our horizontal axis. So I'll do a make coincident to the midpoint of one of our arcs to the horizontal axis. I'll say, okay. Also on here, the arc center is aligned to the center of this arc slot. So we'll do make coincident that as well. Same coincident, the center of this arc to the center of this arc. Say okay. This is 10 millimeters wide. And we know that it is 22 millimeters long from end to end. 22 millimeters. Now, what's nice about this is the fact that the width of the base here is actually being driven by the essentially like the length of this slot. So this is 56 right now, but if it changed to like 50, notice the entire thing is going to update because we made this coincident here. Same thing, same sort of thing with the length. If the size of the slot can change without affecting the overall length of the base, well, we can also make that shorter as well. So yeah, we have geometry here referencing other pieces of geometry rather than everything having their own size. Makes it easy to update and keep the design intent in mind. Sketch is fully defined. If not, if your sketch does not say fully defined, make sure that you've got like the tangent constraints on there. Make sure you have everything coincident. See what is see what lines are that brown color, and go back and see if you can move one of those around. See what's not fully defined. From here we can say finish. And now before we do the extrudes, what we're actually going to do is we're going to make a couple of expressions here for us. First expression is going to be the base thickness. So we're going to have the thickness of the base of the belt tensioner here. This will be 12 millimeters. And then we're going to add another expression for what we're going to call the boss thickness, or this round feature that's slightly taller than the base. That's our boss. That's 2 millimeters taller than the base here. So technically it's 14, and we could add that 14 in, but we're actually going to create a couple of expressions for these. So back in NX, we'll go to our expressions, and you can either hit Control E to bring up your expressions, or you can go to Tools and then Expressions, either way. Our first expression that we'll add in is we're just going to base thickness. You don't have to call them this exact same thing. You can just say base th if you want to, whatever makes sense to you. Call that base thickness, and then the formula that we're going to do is we're just going to say 12. Okay, we're just going to say 12. You can keep all this the same, and we'll say apply. And then I'm also going to add one. I'm going to say boss thickness. And the expression for that, or the formula for that, is actually going to be, I could say like 12, or I could say 14 here. I'm not going to, though. What I'm actually going to do is I'm going to reference the base thickness, say base thickness plus 2. This way, if our base thickness changes to, like, let's say 15 millimeters, our boss thickness is going to stay 2 millimeters above that. So no matter what we change the base thickness to, the boss thickness will be taller. If we need to come in and change this from 2 millimeters to 4 or 5, we can just change this value here. So I'll say apply on that so we can see that. Yes, and it's really nice that we also see the actual value. So here's our formula and here's the value. We can say OK on that. And we'll go ahead and go to our extrude. Now on the extrude, we don't want to use like the connected curve or the tangent curves. We don't want to use any of those because what will happen is if we select one of those, it's going to want to select like the continuous curve, which most of the time is fine for us. We don't want that. What we want to actually select is just this inside area. So we don't want to select the boss because we're going to do two extrudes here, one for the base and one for the boss. So we'll do this like first step and then this raise section. So I just want to select this area here. So rather than saying connected curves or tangent curves, I'm going to go down to region boundary curves. Region boundary curves allows us to select an area. So you'll notice that as I approach the sketch that we have this area that turns red. This allows us to select an area to extrude rather than selecting curves. So we're going to go to region boundary curves, and we want to select this inside area. So anywhere along this base flange. So that's what we'll actually select. We'll click on that. And the distance that I have here is 12, which is technically correct, but I don't want to just say 12. What I want to say, I want to reference that expression that we added in a second. And that's going to be our base thickness. So start typing in base thickness. That's what we want. And I'll say OK. We'll do the same thing again. Go back to our extrude, region boundary curve. And now I want to select the circle that we made. And instead of saying the base thickness, I want to say the boss thickness expression for this one. But notice that our distance is sort of grayed out. This is because when we use an expression in X for like an extrude, it sort of expects us to use that for the next extrude as well, which I find to rarely be the case, but that's fine. We have to change this back to make constant. So we'll click on this little like equal sign here. This will open up this drop down, and we'll come down here to make constant. Now we're back to where we can actually type in a value, but instead of a number, we're going to type out boss thickness. I'll say show results just to make sure that's right. That does look right. I can say it. All right, now we're going to look at this octagon here. It's centered at the origin. It's 24 millimeters wide. That's the largest width. Okay, so that's the bottom. All right, and this tapers up to a 5-degree draft each side. So we'll create a sketch on this face and we'll extrude it up. And when we extrude it, we'll actually add draft in. So we do have the draft tool here, but there's a draft that's built into the extrude tool, which is so we'll create a sketch on the surface of the extrudes on that top face of our boss. Say OK. We'll come up here to our curve section. We have more. We'll go to more, and what we want is a polygon. On the polygon, we want to make sure that the number of sides that we have is 8. We want an 8-sided polygon. And this is sort of like the circle where we are selecting the center of the polygon. So the point that we select is going to be the center of this polygon. We want to make sure that that is going to be at the origin or at the center of the circle. Make sure that it is located there. Now the second click that we have is actually defining sort of the rotation. We can just click anywhere. If we do that, we'll have to add a constraint in later to select the rotation or to stop the polygon from being able to freely spin. With this second click, I'm just going to make sure that I have it located on either the vertical or horizontal axis. Doesn't matter which one, they're both going to be the same for us. I'll just click on this horizontal axis to make sure that we have a constraint here. So just make sure that this can no longer be rotate. It's constrained to this line. We can close out of that, and this is going to be the bottom of our octagon here, and that is 24 millimeters wide. So go back, click on these two sides, and I will say that this is 20 millimeters. Our sketch is fully defined. I'll go ahead and extrude this. Again, it's expecting us to do 14 millimeters for our extrude distance, and it's referencing the boss thickness. This is actually going to be extruded a distance of 12 millimeters. So in order to change this, we need to hit the equal sign right here, go down to make constant. Now we can change this to 12. Before we hit OK, we're going to add in our draft. Go down to the draft setting. If you can't see it, make sure that you click on this arrow to see all the settings. All right, you'll have one called draft. We click on the drop-down list. There are a few options. For us, the only two that are available are start limit and section. We're going to do from start limit. So we want to do from the start limit. And then we have the angle. Look at what's happening here. So it's essentially, as it's extruding up, it's adding in a specific angle. So it's either going in 2 degrees, or we can change to where it's coming out a specific. Right? So we have control over the angle as it is being extruded. Now we're told this is supposed to be a 5 degree, so we're going to do 5 degrees. And it's going in. Make sure it's going in. So it's tapering in is a positive 5 degree angle. And we'll say OK. All right, next we do have a M12 1.75 millimeter pitch threaded hole with a countersink, or with a chamfer, I should say, on both sides. This is going to be at the center of this boss, center of the octagon. So we'll go back to NX and we'll go to our hole tool. It's going to be a threaded hole. Threaded. It'll be a M12 by 1.75. Radial engage, we can just keep the 0.75. Thread depth will be full. On here, so we actually do want there to be a start and end chamfer. Keep those default, that'll be just fine. Now we'll go to our sketch section, and we'll actually start this on the face of the octagon. Now I'm just going to place the point anywhere on the face. We could come in here and add like the make midpoint aligned with like this line, or this line and this line, and that would center us up. But since we already have like the arc center here, and all of the other centers, Let's just pick up on that point there. So I can do a make coincident, and I want the point that I just added to be coincident with this point here. But remember, this is outside of our active sketch. It's there. It's just not in a part of our sketch. So I need to come up and change our selection scope. I can change this to within work part only, and now I have access to all of these points. There's a few points here that we can actually select from. Okay, we just want to make sure that we're using like one of these center. So we've got like the arc center. We've got the point from the sketch. We've also got the origin of our data coordinate system. Make sure that we're selecting one of those. So we can just do like the arc center. Say OK. And we'll finish that sketch. It's fully defined. We'll finish that sketch. I'm going to show result to make sure that we do have the chamfers on both sides. Yes, we do. And I'll say OK. And the last thing that we have to do for this is we are going to go ahead and add in edge blends. So this is R1 rounds as shown. Notice that we have this all around like the perimeter of the part except for the boss and the octagon. On both sides, we're going to add those in along with the slots. So these are R1s. So I'm going to come back and I'll go to Edge Blend. Edge Blend is going to round over the curve. So rather than like a chamfer where we add like an angle, now this is going to actually add a radius to our corners. So we've got this like sharp corner here, but if I set my radius, I'm going to change that to 1 millimeter. I'm going to do this before I start selecting lines. Otherwise, let's say like the default was like 5, and I start selecting lines. Notice that that's a pretty beefy edge blend, and we can get some errors if we do that. So we don't want to do that. I want to make sure I change this to 1 millimeter before I go around the selecting lines. So notice it just like it rounded over that edge. This line right here is where our this face meets this face. That's that edge right there. But if I round that over, that is our edge blend. So we're going to add that in for all of our sharp corners. Edge blends are really important for things like castings and molds. So we really don't want any sharp corners with plastic injection molds or castings. If we have tangent curves or connected curves selected, it'll essentially select everything that's touching that line. Let's say I only wanted to select like this one line here. I could change my selection to like single curve, and now it's only going to select the one curve. And I could just go around and select this. Or I can just keep tangent curves or connected curves selected, and it'll select them all. I can say, okay. What we don't want to do with edge blends is, notice I've got one edge blend in my part navigator. That's because this edge blend represents all of the edge blends that are essentially that R1 radius. What we don't want, let's say that I forgot to do the top slots here. Okay, let's say that I forgot to do those. What we don't want to do is go and make another edge blend and do this here. If I do this, I have two edge blends in my part navigator. Okay, now that's the same radius. if we forget to do something with our edge blend, if we forget to add in something or select lines with our edge blend, and it's the same radius, we're just going to double click back on that edge blend, and then we can select the curves out. Select. And we're only going to add another edge blend if we have another radius to add. So if we had like an R2 or an R3 or whatever, we would want to make another edge blend for that. That's it for this one. Make sure that you submit this to the Dropbox on Canvas. Make sure you save it first and then submit it to the Dropbox on Canvas. That'll be it.